Namaste. Welcome to yet another GATE XE Engineering Mathematics video. In this video, we will be solving 2024 Section 8. Let's start with our first question. Let f of x be pi plus x, negative pi less than or equal to x less than 0, and 0 when 0 is less than or equal to x is less than pi, with f of x plus 2 pi equal to f of x. If capital F of x represents the Fourier series of f of x, then find the value of capital F of negative pi by 2 plus capital F of 0. We have four options: 0, pi by 2 pi and 3 pi by 2. Now, obviously you would think that a function and its Fourier series would or should yield the same result. Okay, well, that is true. But that is true only when the function is continuous. Okay, that is true only when the function is continuous. So if you look at the function's definition here, okay, the definition is changing at 0. Okay, so a possible point of discontinuity is x equal to 0. So let us first go for f of negative pi by 2, right? And that capital F of negative pi by 2 will be equal to the value of the function itself, because at negative pi by 2 the function is continuous, it is in between negative pi and 0. So how much would that be? That would be pi plus negative pi by 2. Okay, now when it comes to 0, you see that the left hand limit, okay, the limit of the function as x tends to 0 from left, okay, that should be, well, pi. Right, because that definition applies to those values of x which are less than 0, right? So what would that limit be? That limit is pi. And what about the right hand limit? The right hand limit of this function is 0, because that value, that definition of the function applies when x is greater than or equal to 0. Okay, now there is a rule in Fourier series that whenever a function possesses a discontinuity, okay, whenever a function possesses discontinuity, like in this case both the limits don't match, so the function is clearly discontinuous, then the value of the Fourier series is given by averaging the left and the right hand limits. Okay, so what is the left hand limit? It's pi. What is the right hand limit? It's 0 by 2, that's pi by 2. Okay, so had we directly substituted the function's value, that is 0, for this one, we would not have got the correct answer. Okay, alright, so what do we want now? We want to add f of negative pi by 2, right? F of negative pi by 2 and f of 0. So if you add them, you will get what? Pi minus pi by 2 plus pi by 2, that is equal to pi, and that is option C. Okay, that is option C. It's not the other option, okay, because we need to take the average of the two values. Now, of course, I don't have enough time to actually explain why that happens, but I'll explain this using a textbook. Okay, so this is B.S. Grewal. If you go to 10th chapter, in my edition it's 10th chapter, Fourier series. So there he talks about functions having points of discontinuity, and if you see the last one, okay, at a point of finite discontinuity, there is a finite jump in the graph of the function. Both the limit on the left and the limit on the right exist and are different. At such a point, the Fourier series gives the value of f of x as arithmetic mean of these two limits. Okay, arithmetic mean of these two limits. So it may be different than the value of the function itself. Okay, in this case it indeed was the case, right? Left hand limit was pi, right hand limit was 0, and the function's value was 0. Correct? But the Fourier series value is asked, so that would be pi by 2. Okay, so question 11, option C. Question 12. Let y be a non-zero quadratic polynomial satisfying the differential equation 2 plus x squared d2y by dx squared plus x dy by dx minus ky equal to 0, where k is a real constant. If y of 1 is 1, then the value of the integral 0 to 1 2y dx is 1 upon 3, 2 upon 3, 1 and 4 upon 3. Pretty simple question. They're saying it's a non-zero quadratic polynomial. So let us assume the standard form. Y equals ax squared plus bx plus c. Okay. And they're saying y of 1 is 1. Okay. Therefore, on substituting x equal to 1, we will get this one. Okay. A plus b plus c equal to 1. Now let us put this function in this differential equation. Okay. Let's calculate the first derivative. Let's call it y prime. Y prime would be 2x plus b. Y double prime, the second derivative, would be 2a. Okay, so let us put that in the differential equation. Therefore, 2 plus x squared into d2y by dx squared plus x into dy by dx, that is 2ax plus b, minus ky equal to 0. Excuse me. Okay. Now what is our job? See, look, this is the satisfaction of the whole function. Okay, that is y equal to ax squared plus bx plus c, which means LHS should be equal to RHS, not for any single or any finite values, finitely many values of x. It should be there for all values of x in the domain. Okay. So let us now compare the coefficients. Let's go to x squared first. So that would be 2a. And again we have got 2a here, right? 2a and then minus ka. Now let us go to x. So we have got bx, so b there, minus kb, okay, minus kb, and let's now collect the constant terms. Constant terms are 4a minus kc, 4a minus kc equal to 0. Correct? What do we want? Oh, okay, we want to determine. Fine. Okay, so because x squared into this plus x into this plus that is equal to 0, we must have each coefficient equal to 0. So I can say 4a minus ka equal to 0, right, based on the first coefficient of x squared. Now a is not equal to 0 because it is quadratic. Okay, if we assume that a is 0, then it won't be a quadratic function, it will be a linear function. Okay, so k should be equal to 4. Yes, k should be equal to 4. Okay, alright. Now if k is equal to 4, what does the coefficient of x give us? Coefficient of x says b minus kb is equal to 0. Okay, now if I take b common, I will get 1 minus k equal to 0, but k is not equal to 0. We have determined that. Okay, because k is not equal to 0, b must be equal to 0. Okay, b is equal to 0. Acha. Now let us come to the third one. Equating the constant term to 0. K is equal to 4, so a minus c 0, a equals c. Go to the data, the first one, a plus b plus c equal to 1, b 0, c equal to 1, therefore both a and c will be individually equal to half because they are same. A is equal to c and their sum is 1, so, well, and they are real, so they should be 1 by 2. Okay. Then what do we want? Okay, so we have determined the polynomial. Okay, f of x or y as they call it in the problem. Ax squared plus bx, so no need to write, plus c, right? And they want us to integrate it. Okay, not that, it's 2y, 0 to 1, 0 to 1, 2y, that would be 0 to 1, so 2y would be x squared plus 1 dx. X squared's integral is x cubed by 3, so that would be 1 by 3 because this is 0. 1's integral is x, so that will again be 1, so 4 by 3 is the answer. Option D. Question 13 on probability. There are 4 cities, namely C1, C2, C3 and C4. The cities are directly connected by 4 roads as shown in the picture below. That is, C1 is connected with C2, C2 is connected with C3, C3 is connected with C4 and C4 is connected with C1. The probability of any road getting independently blocked is 1 upon 3. Let E1 be the event of travelling from C1 to C3 via C2, and let E2 be the event of travelling from C1 to C3 via C4. Then which of the following statements is correct? Probability of union is 56 by 81. Probability of union is 8 by 9. So, well, one of them has to be incorrect. Probability of E1 given E2 is not equal to probability of E1, which is 4 by 9. Probability of E1 intersection E2 is 0. Achha. Look, there are two ways in which we can go from C1 to C3. One is C1 to C2 to C3, and that is the event E1. Okay. In event E1, we can travel from C1 to C2 to C3. Okay. So clearly the probability of E1, if we want to find, we have to first find out the probability of the road C1 to C2 not being blocked. Now all these road closures are independent, right? And any one road being blocked is 1 upon 3. So the probability that C1 to C2 is not blocked is 2 by 3. And so multiplication. C2 to C3 is also not blocked, so that is 2 by 3. So that's 4 by 9. Okay, and similarly I can say that probability of E2 would also be 4 by 9. Okay, probability of E2 would also be 4 by 9. Okay. Now, can we determine the intersection probability? So in any intersection event, what do we basically consider? Both events happen. Okay, both events happen. Now please note that whether we reach C1 to C3 via C4 or whether C1 C4 is blocked, C4 C3 is blocked, that is independent of whether C1 C2 is blocked or C2 C3 is blocked. Correct? Because the road closures between any two cities, okay, those closures are independent of all other closures, I have to say that probability of E1 given E2 should be equal to probability of E1, and that should also be equal to probability of E2, and that is 4. Correct? E1 given E2, well, it doesn't matter whether E2 has taken place or not. Okay, whether C1 C4 is closed, C4 C3 is closed, that is not going to decide whether C1 C2 is closed or C2 C3 is closed. Correct? They have given that independently blocked. Okay, so we have found out that option C is not right because of this part. Okay, option C is not right. Now let us go to option D. They're saying intersection probability is 0. Now, can it be the case? No. Intersection probability is definitely not 0 because, now why is it not 0? Because there is a possibility, okay, I would say there is an outcome in sample space where no road is closed. In fact, what would be the probability of that? Okay, what would be the probability of E1 intersection E2? We can obtain it by multiplying the respective probabilities. Right? We can obtain it by multiplying the respective probabilities, again by multiplication theorem. So that would be probability of E1 into probability of E2. That would be square of 4 by 9. That would be 16 by 81. So D is also not right. Okay, D is also not right. Now we will use addition theorem to find the union probability. Okay, probability of E1 union E2 is probability of E1 plus probability of E2 minus probability of E1 intersection E2. Okay, E1 intersection E2. E1 probability 4 by 9, E2 probability 4 by 9, intersection probability 16 by 81. 4 by 9 plus 4 by 9 is 8 by 9 minus 16 by 81. Take LCM. 72 minus 16. I think that would be 56 by T1. Yeah. So option A is right and not option B. Okay, option A is right and not option B. Okay, so that was the probability question. Question number 13. Question number 14. Assume that f is a function defined on the closed interval 0 to 1 to the set of real numbers. It is continuous on closed interval 0 to 1 and differentiable on the open interval 0 to 1, such that f of x plus h is equal to f of x plus h into f dash of x plus theta h for some theta in between 0 and 1. If f of x is equal to x squared into 1 plus x and theta is expressed in terms of x plus h, then the value of limit of theta as h tends to 0 is 1 upon 3, 1 upon 2, 1 upon 4 and 4 upon 5. So we are given a function whose domain is the closed interval 0 to 1. We are not concerned with its range, but it's a real function. It is continuous on closed interval 0 to 1 and differentiable on open interval 0 to 1, which means LMVT applies. Okay, Lagrange's mean value theorem applies. But to solve this problem, we are not going to use LMVT. Okay, rather we are going to use a fact which we can deduce from these options. Look, each option here 1 upon 3, 1 upon 2, 1 upon 4 and 4 upon 5. This option, well, all of these options show no dependence on x. Okay, so options indicate that the limit is independent of x. Now, if the limit is independent of x, we can choose any value of x, any convenient value. Therefore, we choose x equal to 0 as our choice. It is in the domain and it is also not violating any condition, right? Okay, so if we choose x as 0, then what does the equation given to us become? F of h equals f of 0 plus h into f dash of theta h. Okay, so it's basically this equation that we are writing with x equal to 0. Now let's substitute one by one the terms. Okay, f of h. F of x is x squared into 1 plus x, or I may write f of x as x squared plus x cubed. Therefore, f of h would be h squared plus h cubed, right? F of 0 is 0. H into f dash of theta h. F dash of x is 2x plus 3x squared, right? So at theta h it would be 2 theta h plus 3 theta squared h squared. Okay, now I'd like to diverge here a bit and comment on why can we substitute directly this theta h as x here. Look, the derivative is, okay, let me write it here. Derivative is 2x plus 3x squared, that's right. Okay, but we are evaluating it at a particular value of x, we can say, and that value is 0 plus theta h. Okay, 0 plus theta h. Even if we had differentiated the inner function, that is x plus theta h, we would get its derivative as 1, because theta and h, they don't depend on x, right? Theta and h, they don't depend on x, so that derivative would still be equal to 1. Like, if at all we were interested in finding the derivative by chain rule, that would have not made any difference. Okay, okay, let us now carefully simplify this. H squared plus h cube equals, take h inside, so what would it be? 2h squared theta, right? 2h squared theta plus 3 3h cube theta squared, right? Theta squared is there, but h squared is already there from the derivative of x cube being 3x squared. Okay, so we will get 3h cubed theta squared, correct. Okay, now we can divide by h squared. That's not going to make any difference as h is not equal to 0, it tends to 0. So we can do that. So we will get 1 plus h equal to 2 theta plus 3h theta squared. Therefore 3h theta squared plus 2 theta minus h plus 1 equals 0. That's the quadratic equation that we have got. Okay, that we have got. Now we will solve it for theta. Minus b plus or minus root of b squared minus 4ac. Now we have got 3 there and negative sign, so that will make it 12, and it is h into h plus 1. That's our 4ac. 4 into 3, 12. 12 into this. Okay, 12 into h into that. So 12 h plus 1 with 2 negative signs. One in the formula of quadratic equation, b squared minus 4ac, and one in here. So negative into negative first. Upon 2a, 6h. Okay, upon 2a. Let's now take the limit of theta as h tends to 0. Okay, limit h tends to 0, negative 2 plus or minus root of 4 plus 12 into, okay, let us say 12h squared plus 12h upon 6h. Now look, this limit exists. That's what we want. This limit exists. Now if this limit exists, that's what the options tell us, 1 upon 3, 1 upon 2, 1 upon 4, 1 upon 5, which means it must be in the indeterminate form because of h. Therefore we must have 0 by 0 form. Okay, why 0 by 0? Because denominator is already 0, you can see. H gives 0. And in the numerator, if I put h as 0, I'm getting root 4 inside. Therefore, I cannot have negative sign there. Okay, therefore we drop negative root and continue with positive root. Otherwise, it will not give us 0 in the numerator. Therefore, we get limit as h tends to 0, negative 2 plus root of 4 plus 12h squared plus 12h upon 6h, applying L'Hospital's rule. Okay, by L'Hospital's rule, limit h tends to 0, derivative of denominator is 6, negative 2's derivative is 0, root's derivative is 1 upon 2 root, and in the numerator we'll have 0 plus 24h plus 12. Okay, yes. Now I think this is not giving us 0 by 0, 24h, so that will give us 12. This is 2, root of 4 plus 0, so into 2, and the whole thing divided by 6. 12 upon 4 is 3, 3 by 6 is 1.2. So the correct option is B. The correct option is B. Question 15 on linear algebra. Let A be a 3 by 3 matrix whose eigenvalues are 2, 3 and 4, and I be the identity matrix of order 3. If A inverse is equal to 1 upon 2k into A squared minus 9a plus 13 upon k into I for some integer k not equal to 0, then the value of k is. This is a numerical answer type question. It's a pretty simple one. Okay, this is based on the Cayley-Hamilton theorem. Okay, this is based on the Cayley-Hamilton theorem, which says that every matrix satisfies its own characteristic equation. Okay, now what are the eigenvalues 2, 3 and 4? So what will be the characteristic equation? Okay, characteristic equation would be lambda minus 2, lambda minus 3, lambda minus 4 is equal to 0, or you can also, well, use the relationship between roots and coefficients of polynomials. So we will get lambda cube minus the sum of them, 9 lambda squared, plus sum of the products taken 2 at a time, 3 into 2 6, okay, 3 into 4 12, 4 into 2 8, okay, 2 into 3 6, 3 into 4 12, 4 into 2 8. How much will that be? 26, right? 26 lambda minus determinant of the product, 24, equal to 0. Okay, so according to Cayley-Hamilton theorem, we will now have a cubed minus 9a squared plus 26a. Remember, it is a matrix, we must add or write identity matrix here, and right side is not a number, it's null matrix. Okay, now the standard trick is, if you want to find A inverse, we need to multiply everything by A inverse. Okay, so I write multiplying by A inverse, we get A squared minus 9a plus 26i minus 24a inverse is equal to null matrix. Shift 24 inverse on that side and divide by 24. So we will get A inverse equal to 1 upon 24 A squared minus 9a plus 26 by 24 into identity matrix. Okay. Now let us see whether it matches with this. If 2k is 24, k must be 12. Correct. This is 26 by 24, that is nothing but 13 by 12, again k is 12. So the correct answer to question 15 is 12. So pretty simple. Question number 16, another numerical answer type, and this is based on second order differential equations. For some integer k, the differential equation x squared d2y by dx squared minus 3x dy by dx plus k plus 2y equal to 0 is transformed into d minus 2 squared y equal to 0, where d is d by dt, the operator, and t is log of x to the base e, then the value of k is. Okay, see, there's no need to solve this differential equation, okay? What we need to do is, we just need to find the value of k. So it's more of a transformation problem, changing the independent variable from x to t. Okay, well, this is known as Euler-Cauchy's differential equation from theory. Okay, this is known as Euler-Cauchy's differential equation, where every derivative of nth order is accompanied by that power of x which is equal to the order. So second derivative is accompanied by x squared, first derivative is accompanied by x. It's not there, but if there had been third order derivative, that would have accompanied by x cube. Okay? Okay. Now this is a standard problem, really. If t is ln x, x will become e raised to t, and we can prove that x dy by dx is just d of t, and x squared d2y by dx squared is equivalent to d into d minus 1 times, or well, not times, d into d minus 1 operated on t. Okay, therefore, given differential equation transforms to d minus 1 t, that 3 will still be there, okay, minus 3 into d of y, dependent variable is still y, plus k plus 2 y equal to 0. Excuse me. Okay, equal to 0. Now we are done. All we need to do is simplify the terms, taking y outside. Okay. Okay. So d to the power 2 minus t minus 3d plus k plus 2y equal to 0. But this is actually d minus 2 the whole squared. That's given to us, isn't it? That's given to us. So on comparing the operators, what should k plus 2 be? K plus 2 should be 4. Therefore, k should be 2. Apply a minus b bracket squared, a squared minus 2ab plus b squared. So this would become d to the power 2 minus 4d plus 4. That minus 4d is taken care of by negative d and negative 3d. So k is equal to 2. Correct option to question 6. Not option, the correct answer is 2. Question number 17. The approximate value rounded off to 2 decimal places of the integral from 0 to 1 upon 2 e to the power negative x squared dx using the trapezoidal rule with step size h equal to 1 upon 8s. Now, this is an extremely easy problem, but it is time consuming because you have to find everything on the calculator. Okay, you have to find everything on the calculator. And that on-screen calculator, that is very inconvenient to use. Okay, so it's definitely worse than this one. Okay, so I'm going to use this to find the values. Okay, okay. So what does trapezoidal rule tell us? It tells us the integral is approximately equal to h by 2, so 1 upon 16 into value of the function at the endpoints plus 2 times the values of the function at all intermediate points. Okay, so first it will be 1 upon it, first one, then it would be 2 upon it or 1 upon 4, then it would be 3 upon it. Don't write 4 upon it because 4 upon it is 1 upon 2. Okay, so that's what we need to find. F of 0, that's 1. 1 upon 2, x squared is 1 upon 4, so e raised to negative 1 upon 4, oh my god, 2 into e raised to 1 upon 8, negative 1 upon 64, e raised to negative 1 upon 16 plus e raised to negative 9 by 64. Okay. Well, I don't know how the people who wrote this exam solved this problem. Anyways, 1 upon 16 into, I think it could have been much better, 1 plus e raised to minus 1 by 4 plus 2 into bracket, let me close that bracket. Okay, first we have got e raised to negative 1 by 64 plus e raised to negative 1 by 16 plus e raised to negative 9 by 64. Okay, that's 0.460. Correct up to second decimal please. So that's 0.46. Okay, that is 0.46. Okay, that's question number 17. Question number 18. This is now a 2 marks question. Consider f of z equal to e raised to z, where z is equal to x plus I y and I is equal to root of negative 1. Which of the following statements is correct? F is periodic, not periodic, mod f is 1. Argument of f is pi plus or minus n pi for all values of n, 0, 1, 2, 3 and so on. Okay, it's a pretty simple problem actually. Let us separate x and iy parts. Okay, so that's e raised to x into bracket cos y plus I into sin y. Okay, cos y plus I into sin y. Now look, we know that both cos y and sin y are periodic. So look, f of z is periodic with a fundamental period 2 pi, because cos of y plus 2 pi is cos y, sin of y plus 2 pi is sin y. Cos of y plus 2 pi is cos y, sin of y plus 2 pi is sin y. So that's definitely periodic. So option B is gone. We can also check the validity of option C and D. We know they are not true because they say which of the following statements is correct. That means only one option is right. But still, let's go to C now. Okay, look, what is mod of z, f of z? That's e raised to x into mod of cos y plus I sin y. We know that is unimodular, that means its mod is 1. So e raised to x is the mod of f of z, and that's not always equal to 1. So C is also not right. Not 1. Okay, in general. It is 1 sometimes. Okay, when will it be 1? When x is 0, then it will be 1. But not otherwise. Okay? Fine. What about D? What about D? Look, argument of f, if we want to find, it will not be y plus or minus n pi, it will be y plus 2n pi. Again because of the periodicity, after y, we have to come to y plus 2n pi. Well, we may say it's real part upon imaginary part upon real part, then we have to take its tan inverse, that's all fine. Okay, but even when we discuss the argument or amplitude of a complex number, we make a clear distinction between whether the number is in the first or in the third quadrants. For both of them, y upon x is positive, and for the second and the fourth quadrants also we make a clear distinction, although y upon x is negative. Okay, so D is not right, it's only A that is right. Fine, that is question number 18. Question number 19. Let P and Q be two square matrices of the same order. Then, which of the following matrices is or are necessarily equal to P plus 2Q the whole square? Now this is a multiple select question, could be, because they are saying is or are necessarily equal. Okay? Okay. Let's now go to P plus 2Q squared. That is P plus 2Q into P plus 2Q. Apply the distributive and associative properties. P into PP squared. P into 2Q is 2PQ. 2Q into P is 2QP, not necessarily equal to PQ, plus 2Q squared. Okay. So clearly D is right, because D itself is this, right? Okay. Now let us come to A. A can't be right. Okay. PQ is not necessarily equal to QP. PQ is not equal to QP always. Okay. In general. So A is not right. Okay. Now what about option C? See, option C is right, because matrix addition is commutative. Right? Matrix addition is commutative, so A plus B will be B plus A. So when I write P plus 2Q into P plus 2Q, I may reverse this order and write 2Q plus P. That's fine. It's not going to change. Okay? So C is right. C is right. What about D? What about D? Again, matrix multiplication is distributive. Matrix multiplication is distributive. Okay, what does it mean? It means P plus 2Q into P plus 2Q, that is P plus 2Q squared, can be written as P into P plus 2Q plus 2Q into P plus 2Q. And now we can take that 2 inside. Okay, we can take that 2 inside without changing anything, so that will be Q into 2P plus 4Q. That's allowed. So option B is also right. So how many options are there? 3 options are correct. B, C and D. A is not right. Question 20. If integral from 0 to alpha, integral from root of x by alpha to 1, e to the power y cube dy dx is e minus 1 with alpha positive, then the value in integer of alpha is, again a numerical answer type question. Acha. Look, what is the integrand? The integrand is e to the power y cube. It's not directly integrable. Okay, so we reverse the order. We say this is not directly integrable. So we change the limits. Rather, we say we change the order of integration. Okay, currently what do we have? Here this x is present, which means the inner variable is y and the outer variable is x. Correct? X's limits are 0 and alpha. Okay, x lies in between 0 and alpha. And what about y? Y lies in between root x upon alpha and 1. Okay, let's try to identify the curves. X is equal to 0, x equal to alpha and y equal to 1. All three are lines. Okay, and now suppose we go for x by alpha root equal to y. I can say y squared is equal to x by alpha. Okay, y squared is equal to x by alpha. Now let's plot the region of integration. Okay, let's plot the region of integration. Suppose these are our axes. X equal to 0 is this. Okay, x equal to 0 is this one. X equal to alpha is this one. Y equal to 1 is this one. Okay, and now we have to plot y squared equal to x. Now look, we have even powers of alpha, right? We have even powers of y. That means it has to be symmetric about x-axis, right? And we know how it is going to look. Secondly, we can easily identify that it is going to pass through this point, because if y is equal to 1, then x must be alpha. So this is going to be the boundary. Okay, that's the parabola. Okay, and what is the interval of integration? Interval of integration will be this one. Okay, because it's not the below, because the lower limit on y is not 0. The lower limit on y is this. Okay, now can we express the same region? Can we express the same region using inequalities with limits on y first? Yes. Limits on y are now 0 and 1. Limits on y are 0 and 1 clearly, because this is y equal to 0. Now what are the limits on x? Okay, what are the limits on x? Look, to find the limits on x, okay, to find the limits on x, we draw a line, or we imagine a strip like this. Okay, we imagine a strip like this. Where does it first intersect or meet our region? 0. Correct. Now, while leaving the region throughout, we need to consider the boundary, the blue curve boundary, that's parabolic boundary. That is y squared equal to x upon alpha. So what will x be equal to? X will be equal to alpha y squared. Okay, because this boundary is y squared equal to x upon alpha. So to correctly represent our interval region of integration, area of integration, we need to carefully choose the upper limit on x, that is given by this particular curve. Okay, so we have y going from 0 to 1, x going from 0 to alpha y squared, e raised to y cube dx dy. Let us first integrate it with respect to x. So that will be just x with lower limit 0 and upper limit alpha y squared dy, right? 0 to 1, e to the power y cubed into alpha y squared dy. Now let me divide by 3. Okay, so that will be alpha by 3, 0 to 1, e to the power y cube into 3y squared dy. No need to substitute because we know y cube, if we substitute 3y squared dy will be dt. So finally the integral will be e raised to y cubed with limits 0 and 1. So alpha by 3 into e minus 1, but the actual answer is e minus 1. The actual answer itself is e minus 1, so alpha will be equal to 3. Alpha will be equal to 3. Okay, so question 20. Well, I think this was worth solving. Definitely not that trapezoidal rule in that question. Okay, fine. By far, well, this is the second last problem in our paper, and this is, I think, one of the could be challenging problems. Okay, let's now go to the last one. Question 21, last one. Consider the vector field f bar given by 2x plus y squared I cap plus 2xy plus 3y j cap and alpha m equal to integral f bar dot dr bar along Cm. M can be 1 or 2, where C1 is an arc of unit circle connecting the points 1, 0 and 0, 1, and C2 is a straight line connecting the points 1, 0 and 0, 1. Then the value in integer of 2 into alpha 1 squared plus 3 into alpha 2 squared is. Again a numerical answer type question. And I think this is the only question from vector calculus in this year's paper. Acha. Now let's draw the figure first. Let's draw the figure. So this is it. We have x and y axis. The blue one is our unit circle. Okay, this is our point 0, 1. This is our point 1, 0. So clearly the line, green line, will have its equation x plus y equal to 1, and our unit circle will have its equation x squared plus y squared equal to 1. Okay, fine. Now we want to find the line integral. Okay, and it is connecting the points 1, 0 and 0, 1. So let us assume the sense to be this one. Okay, 0, 1, 2, 1, 0, 2, 0, 1, 1, 0, 2, 0, 1. So along the line it will be this, along the curve it will be this. That's anti-clockwise. Okay, so the value along this first one is okay, C1 is the circle and C2 is the straight line. Okay, now observe this. If we find the curl of f bar, okay, if we find the curl of f bar, partial x, partial y, partial z, 2x plus y squared, 2xy plus 3y and 0, clearly because it does not have any any k component, and it also does not have any z, okay, the curl will be along k bar. Okay, you can check it. I cap into partial 0 with respect to y minus partial 2xy plus 3y with respect to z, so 0 I cap, minus partial 0 with respect to x minus partial derivative of 2x plus y squared with respect to z, so 0j plus, now this is important, partial derivative of 2xy plus 3y with respect to x, that's 2x, minus partial derivative of 2x plus y squared, oh sorry, partial derivative of 2xy plus 3y with respect to x is not 2x, it's 2y, sorry, it's 2y, right, because x is derivative is 1, yes, minus partial derivative of 2x plus y squared with respect to y, 2x is derivative 0, y squared is derivative is 2y, and what do you find there? What do you find? You find that curl is 0. Okay, you find that curl is 0. What does it mean? It means f bar is irrotational or conservative. Okay, what does it mean? It means it is a point function and not a path function. Okay, which means the integrals value, line integrals value is path independent. Okay, it is path independent. Therefore, see, we can choose any path of integration. We can choose straight line. I think let's choose straight line because it is easier. Okay, let us choose straight line because it is easier. Okay, so alpha 1 and alpha 2, they both are one and the same. Okay. Now for our path along the line, can we get the limits? Let's see. Okay, for our path, can we get the limits? Okay. Integral of 2x plus y squared dx plus 2xy plus 3y dy. Okay, any curve would do, so we are following C2. Okay, so for C2, what is the equation of C2? X plus y equals y. So y will be 1 minus x, right? Y will be 1 minus x. So the first integral would be x going from, wait, x is actually decreasing. Yes, x is decreasing from 1 to 0. 2x plus 1 minus x bracket square dx plus, now let us go to y. Okay, y, so in y, well, in dy part, I can write x as 1 minus y. So it would be 2 into 1 minus y into y plus 3y dy, with limits on y being 0 to 1, because now y is increasing because we are moving upwards. Okay, so all we have to do is we have to just integrate these two things to find the values of alpha, the value of alpha 1 and alpha 2. Okay, let's go with the first one now. 2x, so it's x squared. This, it would be 1 minus x bracket cube by 3 with that negative sign. Okay, from 0 to 1, 1 to 0, 1 to 0. Okay, now look, it's 1 minus y here, right? If we multiply it by 2y, first term will be 2y, whose integral will be y square. Okay, and then we have got minus 2y squared. Y squared's integral will be y cube by 3. So minus 2y cube by 3. And this is plus 3y squared by 2. Okay, going from 0 to 1. Okay, now let us substitute 0 first. So it will be negative 1 upon 3 minus, now lower limit 1, so 1 minus 1, 0, so 0. Okay, plus here let's only put 1 because 0 is not going to matter, so 1 minus 2 by 3 plus 3 by 2. Okay, fine. Minus 1 upon 3 minus 1 plus 1 minus 2 by 3 plus 3 by 2. Okay, yeah. So minus 1 upon 3 minus 2 by 3 is minus 3 by 3, that's minus 1, that will cancel this. So eventually we'll have negative 1 plus 3 by 2, that is 1 upon 2. Okay, now last step. So we have got both alphas, alpha 1 and alpha 2, they both are equal to 1 upon 2, and therefore alphas 2 into alpha 1 squared plus 3 into alpha 2 squared would be 2 into bracket. Alpha 1 and alpha 2, they are same. So that would effectively be 1 plus 3, 4 into alpha squared. Alpha is 1 upon 2. 1 upon 2 squared is 1 upon 4. 4 will go, so the final answer is 2. Okay, so the final answer is 2. So that completes our discussion on GATE XE 2024 Engineering Mathematics. If you have any further queries, or if you have not understood any of these problems, then you can drop me an email. The email ID is mentioned in the video description. Thank you for watching. All the best for your GATE preparation. Thank you.